We're going to talk a little bit about studio strobe science, and we're going to be working with that, and then we'll, if we have questions about metering for light ratios and stuff, we'll come back to that kind of stuff. But I want to explain to you watt seconds. And so watt seconds are a measure of the capacity of a flash, much like a gas tank is a measure of how much gas a car can hold. It doesn't translate into how powerful that flash is necessarily, or how powerful a car is necessarily. Watt seconds say this flash can store this much power. And so generally, the more power you can store, the brighter the flash. And so that sort of works out. But that electricity has to be translated into light. So what happens is when you plug your light in, that energy is stored in the capacitor. So the watt seconds is saying this capacitor can store X amount. So 1200 watt seconds, 24 watt seconds, 500 watt seconds, whatever it is. But when you push the shutter release and trigger that flash, that power has to go through some circuitry, and that circuitry does some things like trying to regulate the power in certain ways so that the color temperature is consistent and so that the flash illuminates the exact same amount every single time. There's a bunch of stuff that's happening there. And then that flash tube translates that energy either into heat or light. And so I actually did a test with a bunch of studio strobes to see if you had 5 different brands of studio lighting, and they were all 1200 watt seconds, and they were all set to maximum power, are they all going to have the same amount of output? And the answer was no. In fact, we had some of the strobes that had double the power, twice the power. Specifically, the Pro Photos had twice the power and a lot of things than other brands. And we had to remove some of the brands because they performed so poorly, and I got in a lot of trouble for including their poor results. And so this video is on YouTube. You can Google it. But I compared all these different flashes, and what we found was that, some flashes worked much better than other flashes. Pro Photos worked very, very well, and surprisingly, we had some of the lower end lights that we didn't think were going to behave as well that worked pretty darn well, like the Einsteins, the Pulsey Buff stuff, the White Lightnings. Those guys are pretty efficient. And so, don't get me wrong, you don't have to spend thousands of dollars on a flash. But then the other thing that we found was when we actually added our modifiers, in other words, our reflectors, so not all flashes come with the same type of reflector, that's where the crowd sort of separated, because with the Pro Photo lights, with their magnum reflectors and their parabolic reflectors and those things, we were able to get so much more light out of those than all the other brands that it was sort of ridiculous. And we didn't say that in the video because we didn't want to be so partial to one brand, but there was no contest in this, and now I guess I can say that. But yeah, so all flashes are not created equal as far as power is concerned. The other thing that happens with the building up of your power is the recycle times, like how fast can a flash recycle and be ready to go. So these guys right here, if I set this at full blast, I'm going to hit test, 1, 2, so it's about 2 something seconds, right? 1, 2, 3, almost 3 seconds, so 2.5, 2 3/4 seconds. That's not super, super fast, but that is a pretty darn bright light. If you had some higher end strobes at full power, you could go much, much quicker. But watch this. If I take this and put it at its lowest power setting, which is still pretty bright, this guy right here, I think it'll shoot at something to the tune of 10 to 15 frames per second, which is faster than most cameras can shoot. And so, and it's not going to overheat. It'll just do that all day long. And so the refresh rate for shooters that want to capture action and things like that is an important thing. And so different flashes behave differently. So take that into consideration. And if you're not sure, if you're looking at equipment and you're thinking, which one should I use and which one has a better refresh rate and all that kind of stuff, rent it. Just rent it. And if you can't find a place that rents the gear that you want, then think about the implications of that. If you ever want to rent a different modifier or an umbrella or a softbox, you're probably not going to be able to because they don't rent it. And so you'll have to purchase all your stuff instead of renting different things. So yeah, there's that. The other thing that is a consideration of different studio strobes is the consistency of the color temperature. And what happens is when the flash fires at full blast, you'll get a color temperature that's at a certain place. Usually it's 5,500 Kelvin. That should also be exactly 5,500 Kelvin when it's at the lowest power setting. And when you fire rapidly, it should be consistently at 5,500 Kelvin, or whatever that color temperature is. That it should always be the same no matter what power setting, no matter how fast you're shooting. The color temperature should remain the same. And this, by the way, is the thing that led me to use Profoto lights, because I used to shoot a lot of catalogs where we would have multiple models and they would come out in an outfit, click, 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 and the next one, click, 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 and they all had to be color correct because they would go to an art department, they'd have to go to a catalog. And so if there were any consistencies in color, then the art department, A, would get really angry, and secondly, they would never hire me again. So it had to be consistent. And what I found was with speed lights, the color temperature varied wildly. And with speed lights with batteries, the exposure varied wildly from shot to shot. So if you're shooting bam, 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 and you need everything to be consistent, then that's where you need to consider getting higher end gear, because it's very, very important. By the way, I don't want to say the brand, but I mentioned them earlier. They're not this one. They had the worst color temperature variation. So those lights that were affordable, when it came to color temperature, they were not very good. We used a color meter to measure that from shot to shot, and it was just like a roller coaster. Wow. So think about that, and you'll see that as you're shooting. Okay, before we go on, are there any questions before we hit the inverse square law?
No, I think you answered the question. There were questions about, just questions about the watt seconds, so I'm glad that we covered that.
Okay. You guys have any questions on watt seconds? It's pretty self-explanatory. It's like a gas tank. It works. Okay, now we're going to go to something that I love, and that is this thingy right here. This is the inverse square law, and I'll move this so you guys can actually see it. You guys are good at math, right? So solve this, and S is 16. No, kidding. I don't even know how to read that. So the inverse square law says this. This is a law that says, and I'll just read it to you because I don't know that. An inverse square law is any physical law stating that a specified physical quantity or strength is inversely proportional to that square of the distance from the source of that physical quantity. Blah. What does that mean? So what that means is it's describing how light falls off as it travels. And it works like this. And for those science buffs that are watching, I know this is specific to a point source of light. So a point source of light is like the sun. It's a round source of light. We're going to be demonstrating this with a large softbox, which is not a point source of light, but the inverse square law still works. It just doesn't work exactly mathematically the way I'm showing you. So it doesn't really matter. You'll see that it works and it's amazing. And this is how you can shoot groups with one big light. This is how you can do all kinds of stuff once you know this. You can have a really bright room and you can make it completely black. You can do all kinds of really neat things with this law, and it's very, very simple to understand. So here's how it works. If we look at our light source, and I've gotten so many emails about this. It's not a point source of light, I know. So we're going to get over that. And at 1 foot, if that's 100%, so let's say it's 1. So 100%. If we go from 1 foot to 2 feet, how much less powerful is our light? And so a lot of people think, well, if you double the distance, it's half as powerful, and if you double it again, it's half as powerful. But that is not how light works. In fact, it's inversely proportional to the square of the distance. So if we go to 2 squared is 4. The inverse proportion of 4 is 1/4. So you take 4, you flip it upside down, it's 1/4. So this light goes from full power to a quarter power when the distance is doubled. And then when you go to 3 feet, it's 1/9 of full power, and it's exponentially dropping off. And so this is sort of difficult to see. And all these numbers are just squares. So 5 squared is 25, 6 squared is 36, 10 squared is 100. And so that's where we're getting those numbers. So it's inversely proportional to the square of the distance. Okay, make sense so far? All right. So let's talk about what that means in percentages, because this is where it sort of makes more sense. So the light at 1 foot is a 100% power. At 2 feet, it's 25%. That is a giant drop, right? And at 3 feet, it's 11%. And then at 4%, it's 6. So between 4 feet and 10 feet, there's only a 5% change in power. So what that means is light works something like this. Something like this. Yeah, there we go. This curve goes totally powerful, and then it just sort of coasts. So what we can do with that is pretty amazing. What we can do is we can take and we can put somebody close to the light, and this light is so much brighter than this light that essentially when we expose for this is pitch black. And so we can take a room and we can make it completely dark just by putting a light really close to our subject. It's really cool. Or, remember what we talked about yesterday when we had, you three guys up here, and we were spread out, and we were saying, how do we get light here that's the same as light here, that's the same as light here? You see how this is working out now? What if we had a person here, and a person here, and a person here, and a person here? That's over 3 feet. The light is essentially the same. There's only 1% difference in the intensity of the light at that point. And so that's how you can get consistent light on a big crowd. So instead of a lot of new photographers, if they have a big group of people and they're trying to light them, they get the lights and they put them really close to light all those people up, which is the exact wrong thing to do. Yeah, because what you're doing is the people in the front are really bright and the people just a couple feet back are almost in complete darkness. So instead, what you should do is you should take that light and move it as far away as you can, and then keep these people in this part of the scene, and they're all going to be lit pretty much the exact same. Pretty cool, right? So, and it's, John, I think, said it earlier. He said the inverse square law, I'm paraphrasing, is you put a light close and the background goes dark.
Yeah, the closer you are to the subject with the light, the darker the background is.
Yeah, basically. That works. It works so well. And so what we're going to do is we are going to demonstrate this because it's really, really fun. So Lex, we're going to have you come out again. Come on out again. And what I want you to watch, if we have a lot of distance between our subject and the background, that lets that light fall off and get totally dark, right? And so we're going to take our light. Let's move it over here. Yeah, I'll give you that. We're running out of space in this one. All right, so we're going to move our light over here. Try to move this table around. Okay, and I'm going to even move it to the other side so people can see. All right, so what we're going to do is we're going to put this extremely close. In fact, we're going to put it to the side like this, really, really, really close. Really close. So this is about, a couple inches, something like that, maybe 6 inches from her face. From her face. Yep, turn that back on. Oh,
It isn't in all the way.
there we go. Okay, close your eyes for a second. Oh, yeah, that was awesome. So now what we're going to do is we're going to put this maybe to about 7. All right, and I'm going to meter this to the camera. Bam. That's f25. So that's probably a little bit too bright. I don't want to totally melt you. We're going to do that. That's f13. I'm going to take a shot there. And we'll do this 2 different ways. We're going to do this to the side so you can see side light. Then I'm going to move this so it's more on axis so you can see that as well. So that was f13, is that right? f13. So that's a bright background back there. f13. We are very, very close. Click. And I'm even going to shoot a little bit farther away so you can see this entire thing. And this is sort of cool. It's a completely dark background. Completely black. Pretty cool. So I think we're seeing, there's like we're seeing some light fall off, I think, from these guys right here, which is not horrible. And on my computer calibrated screen, we don't see that. So the screen in the studio here has a little bit more of the shadow detail. I'll even put this about right here, very, very close. And then let's meter that. I'll see if I can actually take a picture here. What is that? 13, okay. Don't try this at home. This is not the way to take a portrait of somebody because it's so distorted. But we're just doing this to illustrate the fact that we can just drop the background out. It just falls right out of there. So it's really cool. All right, awesome. So we have that. Now what we want to do is I want to show you the opposite of that, which is really fun. So to do this, I want to shoot a group portrait. So I'm going to take this softbox off of here. It's a new speed ring. That's not, there we go. Okay. We're going to take this guy off of here, and we are going to use my favorite 7-foot parabolic umbrella. And that is, do you know what that is? Yep. All right, cool. And what we're going to have you guys do is we're going to need all students to hop up. We're going to all hop up. And if you can come back here as well. Come back here as well. Come on, you can do it. All you guys, come on over here. Everybody just sort of get in front of this. And anybody else that wants to hop into the shot. You guys want to come hop in the shot? Yeah, as many people as we can. So just hop into the shot. It's awesome. Awesome, awesome, awesome. Awesome. Camera operators as well. It's at the very top here. At the top, sorry. Like this. Cool. Let me get this. Now what I'm going to do here, there we go. This is a very punchy light. I'm going to move it back about like this. There we go. A little bit farther back. Put this at full blast. Okay, now this is a 500 watt second light. I've done this with, you guys got to sort of scooch, well, you know, yeah, scooch a little bit closer. Perfect. Perfect. All right, I'm going to give you, I'm going to give you that. And then before you do that, I'm actually going to stand in front of this light and then meter that, please. Oh, that says my hair is gone now.
22.
22. Wow, 22. That is a very punchy umbrella. So now we're going to do this shot at 22. Kapowie. And we have this shot, when we bring it up here, we can see that we have a nice shot side to side. We used one single light to do the whole thing. Jim, I think I got you closing your eyes, which is pretty cool. And meter that one more time. Never, ever.
22.
22. All right, perfect. So I'm going to shoot one more shot. Everybody smile, say cheese, say squinch, squinch. Yeah. Squinch, yeah. Squinch, the squinch. Yeah. All right, so we have one light. Now with this, it's pretty cool. We are having some light fall off on the edges, so we might want to have like 2 of these guys, but I've done...
It's from the silver. If you look into the light.
Oh, yeah, yeah.
See, it's
from the silver hotspot there? Mm-hmm. Yeah, so even for this, and you guys can go sit down, sometimes on these shots, what we'll do is we'll use a little bit broader umbrella than this one. If you can take that down, you can sit down. Thank you. You can go down. So that works pretty well. What I've done on almost a similar thing, if you don't happen to have a 7-foot parabolic umbrella like that, I have done group shots of about 60 people, but instead of using an umbrella, I just used a giant white wall. And it works so well. And so I'll see if I can find that picture. It was somewhere on my Facebook page, but I shot a group of students in Florida, and it was 60 people, and we shot it with one light, just one 500 watt second light. We just shot against the wall, and it worked great. Okay, are there other questions before we zip along on this? Yes, sir.
So we've talked about distance and fall off, but isn't there also a part of the inverse square law that pertains to power and number of lights?
I'm sure there is. I just don't know the math.
Okay.
Yeah. Because what happens when you add a second light? And what happens when you do some things like that? Yeah.
one light, you added another light, you doubled it, but to double it again, you have to go to 4 lights,
Right.
then to 8 lights.
Yeah, because it's normal stops.
So it's just going backwards in the inverse square.
Yes, yes. Sort of as stops work the same kind of thing. Yes.
And then this morning when John had his lights out, the LED lights, you said the fall off was
Yes.
different.
It's different because
Again.
this applies to a point source of light, a very specific type of light.
Okay.
LED lights don't behave the same way. And so what's happening, Wikipedia has all kinds of charts and graphs that you'll love. But light doesn't travel from a point source, it doesn't travel straight. It travels in a sphere.
Okay.
And so what's happening is the light it's not really getting less and less, it's actually traveling out more and more. So less of the light is going where you want it to go because it's going in other directions. Energy can't be destroyed or created, right? So that is going in other directions. With an LED light, that's behaving in a different way that I don't know.
Okay.
But it's a common problem with LED lights.
But think of a cityscape at night. You can see all those lights on the building a mile away, but none of them are reaching you. So that light's still traveling out. The light doesn't get dimmer, it just goes wider.
Yes.
Oh,
In a cone.
Yeah,
okay.
stars, same thing. Yeah, stars don't light us up. They don't light us up, they just shine on us from the sky. Yes?
I have a comment from Brighton, Texas, who said, "Finally, I get the inverse square law. Hallelujah. Thank you, Mark. You just made it so simple."
Awesome.
So very cool to hear that.
Inverse square law is fun because once you understand it, it keeps coming up over and over and over again. And it makes so much more sense of like, why? I'm moving the light closer and it's just getting darker. Why is that? And then you realize, oh, move it back.
Think of even depth of field. The closer you are to the subject, the more the background is out of focus. It's
Yeah.
sort of the same general principle. As you move back away from it, it evens out the depth of field too.
Yes.
Mark Wallace, I have never heard anyone say that inverse square law is fun. That is a first.
It is fun. It's lots of fun. It's like,
Hey, Mark, I noticed on the umbrella you had the light pointing directly at the center of the umbrella,
yes.
as opposed to when we used the speed light at point you wanted it tilted at.
No, on the speed light, what I was illustrating was if you put it in the wrong way, it won't hit the center.
It won't hit, so you do want it pointed at the center as well.
Right.
Great, I was
Yeah.
confused about that. That was me.
Yes. So I was trying
Great.
to say is because the speed light is on an adapter, if the pole doesn't go at an angle, the light's not going to hit the center of the umbrella. So if you put it in
Gotcha.
the wrong way, it's going to hit the top.
Perfect, gotcha.
It needs to invent a mount for the speed light where you lay it out flat and it just
Yeah.
shoots right up the shaft and then,
Pocket Wizard has one.
okay,
Yeah,
there we go.
the RF
Someone's
shield.
got it.
Pocket Wizard has one.
Great.
Yes.
And Carolina had asked if this theory applies at all to natural light if there's, say, a window instead of a softbox.
It does. It applies to all light. All light is the same. The thing to remember, though, the inverse square law applies to a point source of light. And so the more diffused the light is, the less this law works. That's basically, the bigger the light is, the less the fall off works the same. And so, yeah, it works just like that.